Ready? Good afternoon, children. In continuation to the yesterday's lecture, amino acids. What is isoelectric point? Yesterday I described. Isoelectric point is it is the pH at which amino acid has no net charge. Amino acid has, because deuterion electrically neutral. At isoelectric point, amino acid exists as deuterion electrically neutral. So it is the pH therefore where amino acid has no net charge. It is the pH at which the concentration of deuterion is maximum. It is the pH at which solubility of amino acid is least. At isoelectric point, the solubility of amino acid is lowest. At lower than isoelectric point, the amino acid positively charged because it will protonate, amino group protonates at lower than isoelectric point. pH higher than isoelectric point, amino acid exists as negatively charged because at above that pH, COO minus COOH will exist as COO minus. So above isoelectric point, amino acid exists as negatively charged. Below isoelectric point, amino acid exists as positively charged. At isoelectric point, amino acid neutrally charged, or the concentration of deuterion is maximum, or the solubility of amino acid is lowest. I'll give one problem, please note down. What is the isoelectric point of cysteine? Please calculate. Do it. Do it yourself. Cysteine. What is cysteine? This is cysteine. At most acidic condition, how it exists? Plus. This is cysteine. What is said? pKa1. So pKa1. So this one and this one and this one. Who is the most acidic? At pKa1. When I add OH minus, what will happen? NH3 plus CH2SH, and this will become, who is the most acidic? Carboxylic acid is most acidic. That will ionize. Then next step, who will ionize? pKa2 is this one, and SH, what is that? This. So when I add OH minus, then who will ionize? NH3 plus CH, CH2S minus CO minus. Then next, when you add OH minus, then what will happen? NH2 CH, CH2 S minus COO minus. So now identify the jitter ion now. What is the jitter ion? Electrically neutral. Who is electrically neutral? This is electrically neutral. So what is the JIT P? What is the isoelectric point? So you cannot add pKa1 plus pKa2 divided by 2. That is what? That is not. The isoelectric point now, this is the jitter ion electrically neutral. So it is a pKa2. He has said, who has given this pKa2. So in this case, what is the isoelectric point is? This is the jitter ion. pK of the deuterion and its conjugated acid pK1. What is that? So isoelectric point is equal to 1.96 plus 8.18 divided by 2. This is the isoelectric point of the, if you calculate isoelectric point, the isoelectric point what I measure is this plus this divided by 2, that is around 5.7. This is the isoelectric point. What is the isoelectric point? What you measure? Cysteine has pK1 1.96 and 10.28, 1.96 for this and 10 point for this. The Ka value, the pK value ionization of SH is this one. So in fact it should be pKa2 and it should be pKa3. Therefore isoelectric point is this plus this divided by 2. Let me give one more problem. The major species present in a solution of tyrosine has charge of -2. Write the structure at that pH. Answer this question. What is the answer? Write the answer. What is the answer? First of all, you should know what is tyrosine. Tyrosine. This is alanine. Now, alanine has a phenolic group. This is phenylalanine. Para position OH. This is tyrosine. This is tyrosine. In a most acidic, this is the structure. When you increase the pH, what will happen? Who is the most acidic? Carboxylic group. So NH3 plus, then CH. this will form. Then when you increase OH minus, what will happen? Next, who is more acidic? So what will happen? No. This will become NH2 because its pK is about 9. As that means above pH 9, this NH3 plus 2 plus will be changed into NH2 because here he says 10 means it is more than that. Therefore, add this again OH minus. What will happen? NH2 CH CH2. What is the structure at this pH? O minus COO minus. So what is the structure of tyrosine at pH 10? This is it exists as a negative 1 and 1. So it has a charge of -2. It has a charge of -2. What is the structure of that? It is this. No down. Any doubt you can ask later. Now some common questions are asked. What type of questions often asked? So one question I am giving, please. CH3, CH2, Br, CH3. This is reacted with BM NaOET. You get a structure A. This react with KOH. HCl. You get B. What is its structure? C7H12O4. And this is reacted with Br2. It will give C. What is its structure? C7H11Br O4. And this is heated. You get D. This on reaction with NH3 and heat. It gives isoleucine. Complete the sequence of reactions. Complete the sequence of, or they may not give this. What is the structure? Or I can say E. What is E? Write the structure. Try this. What is done? Now you should understand. What is DEM? Are you aware of? What is DEM? DEM stands for OH. OH. Malonic acid. What is DEM? OC2H5. OC2H5. Diethyl malonate, a reactive methylene compound, DEM. DEM. And what else he has taken? CH3, CH2, CH3H, Br plus DEM. DEM on reaction with sodium ethoxide, a reactive methylene, a negative charge will develop, and that negative will react here and it goes out. So what will form? It forms CH3, CH2, CH, CH3, CH, COOET, COOET. So what is this? This is A. So this is A. So you have got A now. Come on. This is A. A is reacted with KOH. When I react with KOH, it is a base. What base does? Ester will idolize. What will happen? CH3, CH2, CH, CH3, CH, CO. Idolize and sodium salt will form, and with HCl, and it will become acid. It will become acid. So you get it. What is this? This is B. You have got B. B is reacted with bromine. Now let me take it out this. B is reacted with bromine. When this is reacted with Br2, C7, 1, 2, 3, 4, 5, 6, 7. H12, 3 and 2, 5 and 6, 9, 10, 11, 12 hydrogen. O4, 1, 2, 3, 4. So molecular formula matched. I react with Br2, what will happen? CH3, CH2, and CH, CH3, COOH, COOH, and this will become Br. So 12 का जगह में 11, a Br is introduced, and this react with ammonia. Ammonia undergoes nucleophilic substitution here. So what you get? CH3, CH2, CH, CH3, COOH, COOH, and here NH2. Or otherwise, when you heat it, when you here Br is there, when you heat it, this will become Br and H. Gem dicarboxylic acids undergo decarboxylation, and when I heat with ammonia, CH3, CH2, CH, CH3, CH, NH2, COOH. What is this? Isoleucine. Isoleucine does not have iso group. Isoleucine has two stereoisomers. Who and all have two stereogenic centers? One isoleucine and another is threonine, a hydroxy derivative. They show diastereoisomerism. Only two amino acids have two stereo centers. One is isoleucine, another is 309 OH CH NH2 COH. 309 has two stereogenic centers. So isoleucine and this have two stereo. So you should systematically, if you do, how to prepare. So this is one way of preparing isoleucine from using DEM. So sometimes often asked questions like this. At pH 2, 6.5, 9.5. Second, lysine at pH 1, pH 9. Third, tyrosine at pH 1.7, 1, 7, 9.5 and 12. Like that, questions can be asked. Questions can be asked for aspartic acid at pH 1, 3, 7 and 12. 5, histidine at pH 1, 5, 7 and 12. 6, serine at pH 1, 7 and 12. So this homework I am giving to you. So you answer this. So this is all about amino acids. So you can answer. In the next class I will discuss. Please note down. What is the amino acid that has lowest isoelectric point? Aspartic acid. What is the amino acid that has highest isoelectric point? Arginine. What is the amino acid that has greater amount of negative charge at 6.5? The one which has lowest isoelectric point, aspartic acid. Similarly, they can ask you, draw the glutamic acid at pH 0, pH 3, pH 6, pH 11. So like that questions can be. Naturally occurring amino acids, are they L amino acids or D amino acids? Naturally occurring amino acids are L amino acids. Naturally occurring sugars are D sugars. So this is all about amino acids. Now I will give proteins. Children, this is a amino acid. Say one amino acid. This is another amino acid, whoever it can be. This amino acid react, then a new group, functional group is formed by condensation of two amino acids plus water. This group is called peptide group. A carboxylic acid is react with R1, R2. This carboxylic acid plus H2. This is generally termed as amide. It is called amide. This is also amide, but when proteins react, it is like this. When you take food, आप भोजन कर रहे हैं. When animal takes food, खाना खा रहा है, घास खा रहा है. उसी तरह, this is a peptide, but it is not called peptide. It is simply amide. We call this. You cannot use amide, and here we don't call amide. We call this as peptide group. A amide group formed by the combination of a amino acid and two amino acids, that is a peptide. Now when two amino acids react, the compound which is formed is called as dipeptide. A dipeptide has one peptide group. When NH2CH R1COOH plus NH2CH R2COOH plus NH2CH R3COOH. Three amino acids, they join. Then you get a peptide R1 CO NH CH R2 CO NH CH R3 COOH. How many peptide groups it has? A dipeptide has one peptide group. A tripeptide has 1 and 1, 2. A tetrapeptide has 3 peptide groups. A pentapeptide has 4 peptide groups. A polypeptide, which is called protein. A polypeptide is called N-1 peptide groups. So, jitna amino acids minus 1. So, a dipeptide has 2 peptide groups. The one peptide, tripeptide has 2 peptide, and tetrapeptide has 3, and pentapeptide has 4. A polypeptide protein. What is protein? Protein is a polypeptide. Protein is a macromolecule. Protein is not a polymer. Suppose, what is the difference between a macro with a polymer? This is ethylene. When I polymerize, I get ethylene, a macromolecule. Same repeating unit is there, that is called polymer. Suppose I have CH2CH, CH3. What is polymer? Same repeating unit, CH3, CH3. So you call polyethylene, polypropylene. All polymers are macromolecules, but all macromolecules are not polymers. Proteins are macromolecules. Polymers are macromolecules. Polymers are macromolecule, but all macromolecules are not polymers. Protein, because same repeating unit, matlab same amino acid will not be there. The amino acid, different amino acids, they combine and then they give a macromolecule with so many peptide bonds, peptide groups. So that is called as a polypeptide. Polypeptide is known as protein. Now, suppose this is glycine. And this is called alanine. Now, when this combines to form a dipeptide, it can give 2 different dipeptides. I can say one, suppose you see NH2CH2CO, NHCHCH3, COOH. To represent the dipeptide, this one is called GLY, this one is called ALA. So this is called GLY ALA. This stands for. Now another dipeptide it can form NH2CH3, CO, NHCH2, COOH. Then this is written as ALAGLY. It represents. Now, when you write a structure of a peptide, dipeptide, tripeptide, or a polypeptide, you have to start from amino terminal, and the amino terminal should be left side and the COOH terminal should be right side. That is the convention of writing, representing a peptide, maybe dipeptide, tripeptide, whatever it is, it should be. And what is its name? What is its name? Now, when you name IUPAC name, who will be given a preference? Carboxylic acid gains preference. So therefore, this is referred as glycinyl. Glycinyl is a substitute, glycinyl alanine. So it is called as glycinyl alanine. Now, what do you name this one? The preference to be given to where? COOH. Therefore, alanyl glycine. It is named as alanyl glycine, and this is known as glycinyl. This is how the writing, the terminal, while writing you have to start from the amino terminal, and on the right side you have to write a carboxylic terminal. This is the convention of writing, and you have to name as the amino acid, the main functional amino acid, the right, the most, this one, the one which has carboxyl. This is how a amino acid and peptides are referred. Alanyl glycine. ALA, GLY, that difference, and GLY, ALA. Suppose if I ask how many of dipeptides are possible including stereoisomers, suppose alanine, NH2, CH, CH3, CO, CH2, COOH. From ALA and GLY, how many peptides are possible? It is asymmetric center. So therefore plus or minus 2 you can are possible. Now similarly NH2, CH2, CO, NH, CH, CH3, COOH. How many it is possible? This also will give 2. So total 4 dipeptides including stereoisomers. Suppose I ask ALA, VAL, ALA and VAL, how many dipeptides are possible if including stereoisomers? So 1 NH2, CH, CH3, CO, NH, CH, CH3, CH3, COOH. How do you write this one? ALA, VAL. And here one asymmetric center, here one asymmetric center, 2 to the power of 2. Therefore, how many are there? 4. Now, next NH2, CH, CH, CH3, CH3, CO, NH, CH, CH3, COOH. Here one asymmetric center. Here that means here dextro, here also dextro, here levo, here levo, here dextro, here levo, here levo, here dextro. 4. So 2 to the power of 2, 4. Total how many including stereoisomers? Suppose if you say that I have used only L configuration and I have used L, then only 50%. Now I will ask a question. Ly is lysine and ASP. Write the structure of a dipeptide. I say ASP. LYS, write the structure of dipeptide. So LYS, NH2, CH, CH2, 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 NH2, and this is COOH. ASP, NH2, so you have to write, you have to start from the amino terminal of the lysine and then CH, COOH and CH2, COOH. When a peptide is formed, only the alpha amino group is participated, alpha amino. So when these two forms a dipeptide, this will react, NH, and this is this. Now when I ask this, now you write a CH, COOH and CH2COOH, and you write NH2, CH, COOH and CH2, 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 NH2. Which will phosphate? This will phosphate. Therefore, what is that group? NH. This is the dipeptide. So you should understand what you should not use. You should not use what carboxylic acid should not be used while forming. Now this COOH and this NH2 should not be used. That you should take care of while writing the structure of dipeptide. This question was asked sometime long back in IIT. So I will ask one question. Give the structure of hexapeptide that has following partial hydrolysis. What is that? PROALA plus LEU PHE PRO plus PRO VAL plus VAL LEU and PHE on partial hydrolysis. PROALA one fragment. What is this? It is hexapeptide. Let us see that a PRO is there, a ALA is there, LEU3 is there, phenylalanine 4 is there, PRO either has come, PRO either it has come, and 5 it is hexapeptide. It is an hexapeptide. PRO, ALA and LEU and PHE so either also VAL has come here, LEU has come here and PHE has come. So only 5 are there, but it is hexapeptide, means you should understand one amino acid repeating twice. One amino acid somewhere, it is a hexapeptide. So you have to understand there is some amino acid which is repeating twice. So who is repeating twice, that you have to see. Suppose now here ALA is there, ALA, PRO. Suppose either PRO has come. Suppose let us write here, let us try here PHE, here PRO is there, PHE, LEU. Suppose, can we write? Let us see. Suppose PRO, because here PRO is there, here PRO is there, here ALA, PRO, PHE, LEU. Is not there. So let us see. Now you start from this terminal. LEU, PHE, PRO, suppose we will say VAL. So here VAL ended, then here VAL, LEU, PHE. VAL, LEU, PHE. And VAL, PH, PRO. One, two, three, four, five, six. ALU has not come. ALA, PRO, one, two, three, four, five, six, seven. It is hexapeptide. VAL, VAL, PRO, PRO, 1, 2, 3, 4, PRO, PH has come, LU, VL has come, PRO, VL has come, PROVAL. PROVAL, LEU, PHE, PROALA. PROALA has come, and PROPHLU, this fragment has come. PROVL, this fragment has come, and this fragment has come. This is the structure. So, give the structure of hexapeptide that has following structure. So, what is the structure? Understand this. This fragment, VAL, LEU, PH. So, it has come. This fragment, PRO, VAL, PRO, VAL. This fragment has come. LEU, PHE, LEU, this fragment also has come. And PRO, ALA, PRO, ALA, this fragment also has come. So this is the structure. Which of the following is a tripeptide? A question. A, NH3, CH, CH3, CO, NH, CH, 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 CH3, CO, NH, CH, CH2SH, CO minus. B, NH2, NH3 plus, CH, CH2OH, CO, NH, CH, CH2CO minus, CO minus. C, NH3 plus, CH, CH2, NH, CO, NH, CH, CH, OH, CH3, CO, N, CO, NH, CH3, CO minus. D, NH3 plus, CH, CH2, tyrosine group, CO, NH, CH2, CH2, CO, CH, CH3, CO, NH, CH, CH2, PH, CO, NH, COO minus, and here NH, here CH, 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 CH3, CH3. Which of the following a tripeptide? This is alanine, and this one NH2, this is leucine, and this one is cysteine. A tripeptide, one peptide, two peptide. It is a tripeptide. This one serine, and this one aspartic acid. It is only dipeptide, so it is not a tripeptide. This is histidine. This is methionine, and this is proline. This is alanine. 1, 2, 3, 4, a tetrapeptide. It is not a tripeptide. Here tyrosine, and this is not amino acid. This is not amino acid, alpha amino acid. So this is not a tripeptide. So like this is not a tripeptide. So this bond is not a peptide group, and this bond is not a, this bond CO, NH, and this is not a peptide. So it is not a tripeptide. So who is the tripeptide? A is the tripeptide. So that is how you can decide the tripeptide. So what is a protein? A macromolecule. A polypeptide is known as a protein. So how to name the protein? So you can, I have given how to write the, as a practice you can note down, write the structure of GLY, AL, ALA, ALA1, GLY, GLU, 3, ALA, PHE, 4, LYS, GLY, 5, PHE, ALA, 6, GLY, ALA, GLY, I think you have written this. So do some practice, note down this. So these are. When 3 amino acids linked, it is called tripeptide. 4 amino acid, it is called tetra. 5 amino acid, penta. 6 amino acid. And many amino acid linked, and a macromolecule is formed, that is called polypeptide, also known as protein. A polypeptide generally will have more than 100 amino acids. When more than 100 amino acids join and a macromolecule is formed, that is called protein. Protein is classified as in 2 types. One, fibrous protein, protein is classified as two types on the basis of their molecular shape. What is fibrous protein? When bundles of polypeptide chains, run parallel and held through hydrogen bonding, or a disulfide linkage, CH. Suppose here SH is there, another protein SH is there, and the SH they join together, and here NH and here CO, and similarly here maybe NH and CO, and when they join, a bundles of polypeptide chains run parallel and held together through hydrogen bonding or disulfide linkage. A fibrous structure is formed. Such proteins are called fibrous proteins. They are long chain polypeptide chains are in a bundle form and which are parallel, that linear structures. So these fibers are water insoluble. Fibrous proteins are water insoluble. A typical example, keratin, for example silk, even wool. Wool is a typical example. Hair is a typical example, and also known as myosin, present in muscles. So these are all fibrous proteins. Silk is a fibrous protein, wool is a fibrous protein, keratin a typical example. Fibrous proteins are insoluble. What is global proteins? When chains of polypeptides are coiled, chains of polypeptide are coiled in a spherical shape, the protein is called globular protein. Usually these are water soluble, these are water insoluble. And these are water soluble. All enzymes are globular proteins. All enzymes are water soluble. All enzymes are water soluble. All enzymes are globular proteins. Structure of proteins. Protein structure can be defined in several levels. We will not go into so details like biology students go. Biology students study in depth. Primary structure. What primary structure refers? The information regarding sequence of amino acids is called as primary structure. Means how they have, that means GLY, ALA, maybe ALA again PHA, or maybe whatever it is, ASP and LYS, and like what sequence they have. The information regarding the sequence of amino acids present in the They are not polymers, they are macromolecules. These amino acids may not repeat exactly may repeat next, then again some other like this. So a macromolecule is formed. What sequence of amino acids they have in the polypeptide chain, that information, that is called as primary structure. Then secondary structure. The secondary structure describes regular conformation assumed by segments of the backbone. The secondary structure describes the regular conformation assumed by the segments of the backbone. They are found exist in two different forms, two different type of structures. One is called alpha helix, another is called as beta helix. Alpha helix. It is alpha helix, right-handed screw type, left-handed screw type. Note down. The secondary structure describes the regular conformation assumed by the segments of the backbone. They are found to exist in two different forms. One is alpha helix, another is beta helix. For example, it is right-handed. Like this. Left-handed. Like this. So a staircase, your stair is like this, starting right hand side, like this, left hand side. So how they are coiled. So each one is a mirror image of like that others. And in these structures, NH group of this and CO group of adjacent segment, they will have a hydrogen bonding. Suppose here NH and here CO, they will have there is a intermolecular intersegment hydrogen bonding exists between one helix to other helix, adjacent helix. So proteins, they exist in a coiled right-handed screw form or left-handed screw form. How they are, that describes. And tertiary structure and quaternary structure, they are fine structures which decides the biological activity they perform in their applications. In a biological activity, how the tertiary structure and quaternary structure are responsible for a particular protein for its biological function. So they are fine structures which is not described in chemistry, that may be you missed. So there are typical type of proteins, different type of proteins. One is structural protein. Structural protein, that means which creates a strength. Air is a structural protein, or otherwise keratin, structural protein, silk, wool, they are all structural protein. And protective proteins, a different type of proteins present. Snake venom is a protective protein, and blood clotting protein, and some proteins act as an antibiotic. They act as antibodies, and some proteins, antibiotic proteins, different proteins in different application. For example, insulin is an enzyme. Enzymes are globular proteins, I said. So a different type of, various type of proteins. All enzymes also. A different type of globular protein. So various types of proteins. Then one most important property of proteins is denaturation of proteins. Denaturation of proteins. Proteins found in a biological system possess three-dimensional structure, and they perform various biological activities. These proteins are native proteins. The original proteins found in a biological process, biological system, they possess three-dimensional structure, and they perform, the three-dimensional structure is responsible for performing various biological activities. When a protein is subjected, when a protein in its native form is subjected to a physical change, like whipping, like egg beating, you are changing the structure of a protein, the structure you are changing by physical changing, increasing temperature, by chemical change, means by changing pH, or by adding salts, etc., or by whipping. Physical change means by by whipping. When you do these chemical changes, either physical change or chemical change, the hydrogen bonds present in the protein, they disturb, globals unfold, and helix uncoiled, and the original structure may be a secondary structure, and tertiary structure, quaternary structure, they disrupt, and protein loses its biological activity. So destroying the highly organized tertiary structure of a protein said to be denaturation. Denaturation of a protein loses its biological activity because coiling disturbed, tertiary structure destroyed the highly organized tertiary structure of a protein by whipping, by heating, by adding chemicals, by changing the pH or any other. So that is called denaturation. One typical example, boiling of egg. Second, curdling of milk, preparation of paneer from the milk. During denaturation, primary structure of protein is not changed. During the denaturation, secondary, tertiary or quaternary fine structures are destroyed. So therefore the protein loses its biological activity. But the sequence of amino acid is not changed in the macromolecular chain. So denaturation doesn't change primary structure. Denaturation from natural protein is destroyed from its secondary, tertiary and quaternary structure. Thereby the protein loses its biological activity. That is called denaturation of protein. So today I have completed amino acids and proteins. The next class I will teach nucleic acids, vitamins and enzymes. So anything now you can ask. Ask questions. Any question? No question? Thank you.